Welcome to the deep dive. Today, we're shifting focus a bit, moving away from the big headlines.
Right, getting into the real nitty-gritty.
Exactly. We're heading to the industrial front line, looking closely at a piece of equipment that's, well, often ignored until it fails.
The pressure gauge.
That's the one.
Yep.
Specifically, we're doing a deep dive on the Oteco PG 6SG KPA L21K. Quite a mouthful.
Huh. Yeah, we'll probably break that down later.
Definitely. Now, look, this isn't just academic shop talk.
No.
When you think about heavy industry, drilling, sites, huge refineries, power plants.
Yeah, the environments are extreme.
Totally. We're talking pressure measured in, tens of thousands of kilopascals? Control there isn't optional. It's absolutely critical.
Do or die, really, if pressure control fails.
The consequences are immediate. Catastrophic equipment failure, for one. Then the regulatory headaches, safety compromises. It's serious stuff.
That's the core reality we're dealing with, yeah. And the sources we've looked at, they really cut straight to the chase on this. They basically say this environment demands total operational certainty. So for you listening, our mission here is to really get why this specific instrument, the PG6SG KPA L21K, is seen as a kind of frontline defense.
Okay.
And why certain specs aren't just nice to haves. They're absolutely vital. Life-preserving, even. We're going to unpack the engineering behind it, what makes it truly, battle-tested.
Okay, let's definitely unpack that. The stakes are obviously huge, but, procurement teams, they're always under pressure to cut costs.
Always.
They see a gauge, they see a price tag, and that lure of the bargain must be pretty strong. What's the actual risk, the strategic risk, when they opt for some generic no-name gauge?
Well, they're essentially buying risk, maximum exposure, really. It just happens to be disguised as savings. And the problem is the consequences of, let's say, poor quality control, they aren't always immediate. They tend to show up later, maybe when the system's under stress or after it's been exposed to corrosion or vibration for years.
Right, so give us a concrete scenario. How does that decision, buying the cheap gauge, come back to bite an operations director?
Okay, let's use that anecdote from the sources. It paints a pretty vivid picture. Imagine it's 2.15 in the morning.
Middle of the night. Yeah.
Production's running full tilt. An operator needs to adjust pressure on the choke manifold. But the gauge, the cheap one, the non-spec one, it's gone blind.
Blind, meaning broken.
Not necessarily broken physically. It might look fine, but the data feed is gone. Or maybe worse, it's reading inaccurately, say 5% off.
Which could be a lot at high pressures.
Exactly. So the operator may be relying on experience, historical memory. They overcompensate slightly based on what they think the pressure should be.
Uh-oh. And what happens next?
Fast forward maybe 4 hours. That slight overpressurization has triggered a failure somewhere else down the line. A connected component gives way.
Okay.
Production stops. Dead halt. You've just lost maybe a full day's output. That's easily 6 figures, maybe more. And now the regulators are involved. They want failure analysis reports. The audit trail eventually points back to the instrumentation, specifically to that moment of bad data or no data at 2:15 a.m.
So that $500 bargain gauge.
Just potentially cost you $500,000, plus damaged your standing with regulators. That's why reliable instrumentation, it's honestly the cheapest operational insurance you can possibly buy.
That really flips the script, doesn't it? From just looking at the initial price tag to thinking about data integrity, total cost of ownership.
Absolutely.
Sources, they really emphasize Oteco's reputation. Built on, 80 years?
Yeah, 80 years.
But okay, 80 years is history. What edge does that track record give them today?
Yeah.
Against maybe a newer, technically savvy competitor?
It boils down to consistency. And consistency means predictable material science.
Okay, explain that.
Well, look, when a company's been designing and refining things like relief valves and gauges since the 1940s, like Oteco has, they've basically stress-tested their materials against pretty much every operational variable you can imagine, especially in the really nasty environments, oil and gas, chemical plants, utilities.
Because they've seen it all.
Pretty much.
Right.
That longevity means their Model 6 gauge, it isn't just designed to meet the written spec sheet. It's designed to survive all the unintended stress factors, the stuff not on the spec sheet.
Like what?
Like sudden heat spikes, unexpected vibrations, maybe corrosive contaminants that weren't accounted for in the initial design brief. That's the real difference between just theoretical performance on paper and actual proven battle-tested results in the field.
Okay, that makes sense. Which brings us right to the specific component we're focusing on, the Oteco PG 6SG KPA L21K.
Our hero component.
Right. Before we dive into the features, let's quickly break down that model name. It looks like alphabet soup, but for a technical audience, that code is actually packed with info, isn't it?
Oh, absolutely. Think of it like shorthand for its operational readiness. PG is simple, pressure gauge. The key part is 6SG. The 6 tells you the size 6-inch gauge face. And SG is critical. That means it's designed for sour gas service.
Sour gas. We'll definitely need to unpack that one.
For sure. N PPA obviously tells you the units metric kilopascals. And L21K gives you two things, L for luminous dial and 21K for the pressure capacity, 21,000 KPA.
Got it. So knowing that code lets a procurement team instantly verify they're getting the exact spec they need for a really demanding controlled environment.
Precisely. No ambiguity.
Okay, let's talk features. You mentioned the luminous dial face, the L and L21K.
Okay.
Sounds pretty basic, but you described it earlier as having life-preserving clarity. Why so critical?
It really comes down to human factors engineering. In an emergency situation, the human brain needs information fast, instantly processed.
Right. Seconds count.
Exactly. So if an operator is stuck in a dimly lit area, maybe a substation, down in a maintenance pit, or just working a midnight shift on a rig floor,
Yeah, visibility could be poor.
they absolutely cannot waste time squinting at a gauge or fumbling for a flashlight. The luminous dial cuts through all that. It minimizes operator fatigue, reduces cognitive load, especially during a crisis.
So it makes the critical numbers, the red lines, the safe operating zones jump out.
Instantly readable. It ensures that a split-second decision about pressure is based on clear, undeniable data, not some approximation or guesswork.
Makes sense. Okay, now let's get to the really core engineering challenge here. The shear pressure scale. This Model 6 handles 0 up to 21,000 kPa. Why is it so technically difficult to get accurate readings at that kind of extreme pressure?
Well, you're dealing with just enormous physical forces acting on what are actually quite delicate internal components.
Like the needle mechanism.
Primarily the board and tube. Most gauges use one. It's typically a C-shaped, thin-walled metal tube. When pressure increases inside it, the tube tries to straighten out, and that movement drives the needle on the dial.
Okay.
Now imagine that tube under 21,000 kPa. That's over 3,000 psi. It's under incredible stress.
Right.
Lesser metals or tubes not manufactured to exacting standards, they'll start to yield under that pressure. They might deform permanently, drift out of calibration, or just fail catastrophically over time.
So Oteco has to use special materials.
Absolutely. They have to use specialized alloys. And their manufacturing processes have to be incredibly precise, highly calibrated to ensure that board and tube maintains its elasticity, its ability to spring back, and its linearity, meaning its movement is directly proportional to the pressure across that entire massive range.
So it guarantees accuracy even when it's pushed right to its limit.
That's the goal. Industry-leading accuracy, even at the highest pressure peaks. It's not just about surviving the pressure. It's about giving you trustworthy, linear data while under that immense physical strain.
Okay. And that reliability under strain leads us straight into environmental resistance. You flagged the sour gas service rating, the SG, in the model code. What does that actually mean from a material science point of view?
Okay. This is probably one of the most critical distinctions, especially in environments like oil and gas processing, where you often find hydrogen sulfide HEROs.
Right, sour gas. Nasty stuff.
It's a killer, literally toxic to people and absolutely brutal on equipment. The sour gas rating means that all the internal wetted parts, basically anything inside the gauge that comes into direct contact with the process fluid or gas,
Yeah.
they must be highly resistant to something called sulfide stress cracking, or SSC.
That's SC. Sounds bad.
It is bad. It's a very specific type of failure where the hydrogen atoms from the HERO actually penetrate the metal's grain structure.
Okay.
And that makes the metal brittle, prone to cracking under stress. Cheaper metals like standard carbon steels or even some stainless steels not designed for this service, they'll just seize up, crack, or literally dissolve over time when exposed to HERO.
So an Oteco gauge rated for sour gas has to use different materials inside.
Yes. It has to use specific NACE-compliant materials. NACE is the standard-setting body for corrosion resistance. We're talking specific grades of stainless steel, or sometimes nickel alloys, that are formulated specifically to resist this molecular-level attack from the hydrogen sulfide.
And if a gauge isn't rated for sour gas, but gets used in that environment?
You're not just risking a leak from a cracked tube, you're risking a complete catastrophic structural failure of the instrument itself, which means an immediate loss of pressure containment. Very dangerous.
Right, okay. Those specs, they sound impressive on paper, but like you said, it's about performance in the field. So where does this gauge, the PG 6SG KPA L21K, actually prove its worth day in, day out? Where are we seeing these things deployed, solving real problems?
You find them anywhere that data quality equals survival, basically. So definitely on oil and gas rigs.
Doing what specifically?
They're essential for monitoring the exact pressure of drilling mud, for example, or the pressure in the choke manifold. These are absolutely critical data points needed to prevent an unexpected blowout. The sheer consistency and reliability of that gauge reading helps maintain the safety barrier.
And you mentioned earlier, it's not just about preventing disaster, but also about maintenance predictability.
Precisely. Think about petrochemical plants. You've got pipelines carrying volatile, often corrosive materials under high pressure.
High-risk lines.
Exactly. By using a gauge like this that guarantees accurate, reliable data, maintenance teams can actually track performance trends. They can schedule planned shutdowns for preventative maintenance based on predictable wear, rather than just reacting after something fails catastrophically.
Saves money and improves safety.
Both. And it's not just limited to oil and gas or chemicals.
Where else?
Utilities, power generation plants. They use these to make sure turbine steam pressures, boiler pressures stay precisely within their designated safe and efficient operating zones, the sweet spots.
Efficiency and safety again.
Two sides of the same coin in that world. You even see them in some high-end manufacturing lines where process integrity is paramount. This level of durability and accuracy helps cut unplanned shutdowns and ensures the final product quality is consistent.
So when you zoom out, what does this guarantee of quality, this battle-tested reliability, actually deliver for the people making the big decisions? The ops directors, safety officers, procurement managers.
I'd say it offers three key strategic advantages. For an operations director, it fundamentally delivers peace of mind.
Peace of mind. How?
Peace of mind that lets them push for maximum uptime, knowing that the instrument reporting the critical pressure data isn't going to be the weakest link in the chain.
Okay. And for safety officers.
For them, the specific engineering features things like the sour gas rating, the luminous dial. They act as a tangible, undeniable data lifeline. It helps them ensure compliance, both with external regulations and internal safety protocols. The gauge provides verifiable proof of safe operation.
Makes sense. And for the procurement managers, the ones potentially tempted by the cheaper option initially.
Well, for a smart procurement manager, choosing an Oteco gauge like this is viewed as an upfront investment, an investment that drastically lowers the hidden long-term costs. Costs associated with unexpected maintenance, crippling downtime, and potentially massive liability claims if something goes wrong.
So it's a strategic buy, not just an operational one.
Absolutely.
Which brings us nicely to the final piece of this puzzle. Sourcing. Okay, you've decided you need this specific high-quality instrument. That's half the battle. But ensuring you get the genuine article and get it deployed correctly and quickly, that's the other half, right? You need to avoid the uncertainties of the general supply chain.
I really do. Especially when you're sourcing certified safety equipment. You don't just need a vendor, you need a strategic partner. The challenge is mitigating the technical risk during the procurement phase itself.
What kind of technical risk?
Well, you need to avoid making, say, a costly $50,000 mistake because someone installed a gauge rated for 10,000 kPa on a line that actually operates at 15,000 kPa. Yeah. And that can happen if you're dealing with a general supplier who maybe doesn't understand the nuances, doesn't ask the right qualifying questions about the application.
So how does a specialized supplier like PE Energy, who was mentioned in the sources, address that? How do they solve that strategic sourcing problem for, say, B2B procurement teams?
It really comes down to three things based on the material we looked at. First is ensuring authenticity and providing price assurance.
Meaning you know you're getting the real deal.
Exactly. Factory direct pricing on genuine Oteco products. No knockoffs, no gray market stuff of questionable origin. In these high-stakes industries, the tolerance for counterfeit or substandard safety equipment is absolutely zero.
Okay, authenticity is number one. What's second?
Expertise. They offer dedicated B2B support, and this is key. When you call them, you're not talking to a generic call center agent reading from a script.
Who are you talking to?
You're talking to someone who likely has real-world experience, an oil field veteran, maybe someone who's worked in a plant. They understand the specific operational context, the material compatibility issues, the pressure cycling demands, the relevant regulatory mandates.
And that knowledge saves time And prevents errors.
Saves enormous amounts of time, and crucially helps prevent those technical specification errors during the ordering process.
Makes sense. And the third thing, logistics, especially for big companies maybe running multiple sites or projects.
Exactly right. Inventory depth becomes critical for operational reliability. A supplier like PE Energy needs to maintain access to a really wide range of Oteco inventory.
Not just the standard Model 6.
No, including the really specialized gauges needed for extremely high-pressure lines. You know, the Model 7 and Model 8 variants, like the PG 6SG KPA L21K or the PG 8SW KPA L21K we saw mentioned. Maybe relief valves, other related components too.
So they have the stock.
Having that depth and combining it with things like wholesale volume deals for larger orders, streamlined ordering processes, and crucially, rapid shipping. It means your project timelines don't get stalled waiting lists for a critical safety component to arrive.
So their overall promise is about?
It's about delivering field-tested quality combined with real-world, fair pricing and layering on top that technical expertise that ultimately saves procurement teams time, money, and headaches. It prevents strategic risk.
Okay, this has been a really fascinating deep dive. We started off looking at what seems like a pretty small, maybe even mundane component, the Oteco PG 6SG KPA L21K pressure gauge.
Yeah, easy to overlook.
But we've really uncovered its absolutely critical link to huge operational outcomes, things like uptime, production stability, and maybe most importantly, fundamental safety. We've seen how those specific engineering choices, whether it's the 21,000 kPa pressure rating, the specialized materials for sour gas service, even the luminous dial items, they aren't just random features. They're non-negotiable requirements.
Yeah.
Basically forged in the fire of the toughest industrial environments out there.
Yeah, they're solutions born from decades of hard-won experience. And if we kind of circle back, connect this to the bigger strategic picture for a moment, it raises a pretty important question.
Okay.
A question for you, the listener, especially if you're an industrial professional. When your own performance, maybe your career progression, is judged on things like maximizing output and minimizing unscheduled downtime,
Yeah.
how much uncertainty can you really afford to tolerate in what might be the single cheapest piece of monitoring equipment on a multi-million-dollar process line?
Good question.
Think about it. Swapping out a gauge that's just good enough or maybe even suspect for a certified, genuinely battle-tested Oteco solution like the Model 6, it's honestly, and this isn't an exaggeration, probably the cheapest insurance policy you will ever buy.
Insurance for what?
Insurance to protect your physical assets, your production schedule, and most importantly, your people. It's ultimately an investment in predictable, reliable data, and in these industries, that's gold.